The following talk will blend functionality with artistic appeal. Clement is a professional electronic designer building electronic for fun and profit. He will talk about his collaboration with Morag Hickman, professional artist and EMF camp design team lead, in exploring PCB art. Please give him a warm welcome.
Hello, everyone. I'm Clement. This was originally planned to be a two-person talk about how a collaboration looked like from the perspective of two people approaching it from different disciplines. Unfortunately, Morag, my co-speaker, isn't able to join us today. We wrote and prepared this talk together, though, so don't be surprised later when I speak from their perspective as well, or say we a lot. I'm an electronics person. I build electronics for fun and profit. I mostly work on normal, boring product PCBs that go inside the case and are never seen. But I do like to make my circuit boards pretty sometimes. But the best I can do is draw cats and occasional sharks and put them on a PCB. I quickly reached my limits when attempting to go for more ambitious visual designs. And I've since had the very educational and wonderful experience of working with a professional artist a few times on PCB designs. And this is fairly new to me, and I learned a lot in the process. My collaborator, Morag, is an artist who took the long way around via physics, journal publishing, and science communication. They are primarily a sculptor and jeweler, but do traditional and digital art as well. And they led the deco and design team for the Electromagnetic Field Festival in the UK. Morag didn't have any PCB design experience, so we had a lot we needed to communicate to each other across the discipline barrier. This is a half-hour talk, so we won't be teaching you how to design circuits or how to be an artist. There's plenty of other resources for that. We're here to tell you how to bring the two together and collaborate. So the reason we feel we're qualified to tell you about this stuff is that we collaborated on two very different artistic PCB designs for the Electromagnetic Field Festival badges. These are fun and functional devices that attendees use and hack on and build extensions for during and after a hacker festival. And by default, they're used without a case. So we wanted to make the most of the event's theme and extend it to the hardware to make it pretty and special and tie in with the rest of the event. We did the one on the left here in 2022. It was super stressful, but eventually we worked it out. Then we did the one on the right this year, and everything was much easier and smoother and less stressful, because not only had the tools we used improved in the meantime, but so had we. Turns out we're capable of learning from our failures. We wanted to tell you about this so you don't repeat our mistakes and instead can make new and wonderful mistakes of your own. Now, why bother doing any of this? Traditionally, PCBs are the guts of a device and not the face of it. They're made to be hidden away and do their thing, and the cosmetics of a device are in its enclosure. But this is changing. Increasingly, we see PCBs being the main event. They're being made to be seen, and people are experimenting with products without an enclosure and PCBs that combine function and looks. And even if your PCB is hidden, you can still make it pretty just because you can. And people or you can show pride in your work. Many people who work on PCBs actually have personal logos that they put on a PCB just to show they're proud of what they made. And there's even PCBs being made primarily as artworks or shitposts, which have little or no functionality, or where the functionality is primarily aesthetic. The one on the left here is from this year's Easter hack. It's the Cyber Bunny, and it was made by really wonderful PCB designers and artists. The one on the right is from RevSpace, which is a hack space in the Netherlands, and it's just a shitpost. Yeah, there's also boards which mix the functional with the pretty. The one on the left is an earring that lights up in response to sound. The one after that is a bat detector with a bat on it. And then, yeah, of course, put sharks on your PCBs, put badgers on your PCBs. You know, why not? So yeah, why not just plop some art on your electronics? Well, you pretty rapidly reach your personal limits. Some people are good at both electronics and art. If this is you, awesome. More power to you. Sadly, not the case for most people. Once you reach your personal limits, you have to collaborate to make more amazing things. But collaboration is tricky. It requires communication. You have to find a common base of understanding and a common language so you can explain your processes to each other. So if you're an art person, you need to understand PCBs a little bit. If you're a PCB person, you need to understand art a little bit. It doesn't mean you need to switch to the other discipline, but it does mean you need to talk to each other. Okay, so let's look at what circuit boards are and what they look like from an artist's perspective. A circuit board is a conductive perforated lasagna that connects stinky and zappy things, or a precision manufactured product for connecting small electronic parts together in a densely engineered pattern of conductive and insulating materials. Right, they are a building block of every modern electronic device. And PCB manufacturers are really, really good at what they do, which is reliably shaping a consistent stack of materials into sub-millimeter-sized features with extreme precision. Now, we can exploit this manufacturing precision to add visual elements at a similar scale to the component pads of modern electronic components and the traces that connect them, which are really, really small. And PCBs are relatively cheap compared to other technologies that have the same level of precision. And they also scale up and down in volume really well. So you can make small or large quantities without major differences in effort. So circuit boards are made of a consistent set of materials. They typically have a rigid fiberglass epoxy core. And that core has one or multiple layers of copper on each side. And they're sealed in by a layer of colorful epoxy called solder mask. The copper that's not covered by the solder mask is protected by either a very thin layer of silver-colored solder or an even thinner layer of gold. And any spots where neither mask nor copper is present expose the beige-brownish fiberglass substrate underneath. The board usually has some markings printed on it in a contrasting color called silkscreen, because it was originally made by a silkscreen process. These days, usually inkjet or a photographic process, but it's still called silkscreen. The board can have holes in it that are either electrically conductive, called vias, or insulated, and it can be cut to a particular shape as required. Now, how can we use it for art? In Morag's words here, as an artist, it's very easy to look at the finished PCB in its flat as a pancake glory and find there's not much you can do with it. You might look at the map of your designer's circuit and see something you could doodle around or on top of. However, if you look a bit closer, you'll discover a PCB is a three-dimensional object. It's a block made up of layers of different materials with parts sticking out of it, and you can reposition things and cut into it at different depths and get sculptural. And by working together, it's possible to carve away parts of the circuit board, undermine things, add details, and create something textured and complex without ruining whatever functionality the board has. Adding visual complexity to a PCB doesn't significantly impact its manufacturing time or cost. Now, by exposing, shaping, or removing different layers, you end up with a small palette of colors you can use. Because you can choose the color of the solder mask from a small range that PCB manufacturers offer, there's also a few variations in that. And this is what the different layers look like individually, and what the result is when we combine them. And the same thing can be done again on the opposite side of the board. And here's how you can use this to make pretty effects. So on the top left, we have a bee, and the white of the bee is silkscreen, the gold is exposed copper, and the two green tones are green solder mask with and without copper underneath. And the shadow is where the copper has been removed under the solder mask. On the top right, we have all of those, and additionally also mask openings with no copper. And this exposes the underlying fiberglass substrate material, which is a beige brown. On the bottom left, we have shapes on all combinations of layers, but the solder mask, instead of being green, is black. And on the bottom right, we have a black solder mask with a textured silkscreen used for a halftone effect. And the highlights in this image are in exposed gold-plated copper. So you see there's a lot of possibilities there, even though it's a very constrained and challenging medium to work in with a very small palette. If you want to do something like this, here's how you go about it. So you want to plan a cross-discipline project, right? And first thing you need to do is find somebody to work with. You need someone you can work with that complements your skills. This can be hard. In our case, we were lucky enough to be on different teams at the same festival, and things fell into place. I hear there's various hacker events looking for volunteers if you want to try doing something like that. When you start a new collaboration, it's really important to discuss and agree what the core things you want to achieve are. So what does your board need to do? What should it look like? What kind of style or team it needs to have? And you need to be aware what you personally can deliver and be realistic and cross out things that are too much as early as you can. You want to agree on a few fundamentals. So you need to agree on size and shape of the board, its interactions and functionality, and what scale and complexity the design element should have. Now, at this stage, you want to make as many manufacturing choices as possible, because last-minute changes can break a design entirely. So if you change the solder mask color, that can require an entire new visual concept. So you want to make those choices early on. And you want to be upfront about scheduling, lead times, and pinch points. This avoids lots of distress later on. And it's good to have a solid plan, but that plan will collide with reality, and it will definitely fall apart. Don't be afraid to change the plan as soon as it gets in the way. The process of making the plan is much more valuable than the plan itself. Okay? Right. So, next thing you need to do is round trip. And if there's only one thing you take from this talk, let it be this: round trip early, round trip often. A round trip is taking a design from a PCB design tool into an art tool, adding art, bringing it back into the PCB design tool again, and seeing what breaks. It's super useful to do this to demonstrate your workflow to each other. So ideally, you do this together in real time. You talk through what you're doing and why. And it's a great way to get an overview of the tools the other person is working with and get a feel for their restrictions and general philosophy. So to do this, you throw together some sort of PCB. Having the right shape is nice to have, but not critical at this stage. It needs to have circuitry on it, but it doesn't have to be any kind of done. Okay? Then you export it, get it into whatever art software package you're working with, add some really awful quick art. I'm not going to show that, but like we have art for this purpose, which is just like, I drew a cat, I drew a shark. It's on there. Yeah. Okay, and export it, and then try import it back into the PCB design tool. You'll learn a huge amount about what the other person needs from your files. You'll uncover very exciting issues like wonky scaling or file format problems. Thank you, Adobe Illustrator, for not agreeing on what an inch is with other tools. Yeah, okay. Round trip every workflow you want to use. So in our case, we had both raster and vector workflows. Depending on what worked best for the art. They have very different strengths and weaknesses, and it's important to figure out what you're going to use before you spend hours on your art and discover it won't work. So your goal here is see what breaks, repeat until you get what you expect. In 2022, we left this until way too late, and it resulted in lots of extra work. Do this early, do this often. This year was way, way, way easier because of this. Now, you've tested your own tripping, and it's time to design a draft circuit. And here's where I find the concept of design space and constraints really useful. Now, you can't just stick stuff on a board and call it done. It won't work. And there's constraints that restrict what you can do. So, for example, the board may need to be a certain size. It may need to fit within a budget. It may need to run from a battery. All of these things constrain what your design can do. So if you imagine an infinite multi-dimensional space that contains all possible PCB designs, every design constraint is a wall in that space, which eliminates some possibilities. So you have large-scale constraints such as size, cost, power usage, manufacturing process, and they put a big wall in your design space, and everything on the other side of that wall cannot be done. And there's more detailed constraints, like your connectors may have to go on one edge of the board, and some traces may have to be a given size, some vias need to be placed in particular places, and that constrains your design. A very constrained design leaves very little freedom for variation. It has to be a very particular way. And a less constrained design leaves many options for things to move around and change. The design space that remains around the design is where art can live. I know this is a bit abstract, so I'll show you an example. So in 2022, one of our boards had a really constrained design. On this board, we had very, very little freedom on where we could place things. Almost all these traces had to be exactly where they are. We needed a good ground plane, so that's a solid copper around the traces, and we needed the vias to be in exactly those places. And this made it very challenging to make the art fit. It was a lot of effort. And yet, pro tip, octopuses are known for squeezing into tight spaces. You can always fit another octopus. So yeah, in 2024, we took this concept into account from the start and specifically left more design space for art to happen. This made everyone's life easier. So when you're creating a circuit design for collaboration, try to think about how much freedom you're leaving the other person for visual design while putting the layout together. Usually, you don't need all the space on the board, so leave space and be flexible on where things can be. If your PCB has to be a particular shape, it's really useful to get that shape drawn in an art tool and import it before you start on a layout. Okay, so you have a draft design. You need to then export your design. And we need to export it in a way that an artist can use. So we are exporting two things. One, screenshots or renders, as realistic as possible. And these will get drawn onto and used for sketching, planning, and discussion. And this is absolutely critical, because this is basically what your language for communication with your artist will evolve into. And then you want technical layers. That's SVGs exported to scale. And we didn't do this in 2022, and things did not go well for us. Lots of things were off scale, and we needed to manually tweak the scale and see if it sort of fit. And yeah, that was not fun. So you're exporting a separate SVG each for copper, mask, and silk for each side of the PCB. And you also want to export an SVG of the board outline. And then you want to sit down and scribble on it. So you want to plan some time for a longer session together, where you go over the design and annotate it. You will need to understand where you each have space to work in without breaking things for the other person. So you want to annotate, don't touch these areas and things that are important to make the design work. So here's what something like this can look like. So we've exported some screenshots from a PCB design tool and are just drawing things on it and making notes. And here's another one, which is all the purple stuff, please don't touch that. And all the orange stuff, you may break things here. And it can get quite detailed. We'll get back to this picture in a bit for reasons. But yeah, let's look at this from the perspective of actually planning the art. So when you're designing the art for a circuit board, it's important to understand the scale of the features that you can use. So people are looking at your board with their eyes, not with a microscope. And when you're doing circuit design, you're usually really zoomed in and working on very small things. So it's very easy to get lost. You want to be using the technical export layers as a reference for how big things are going to be. So this tells you how big your features and gaps between them can be, and you set your brush sizes to match that. But consider how big it's going to be in the end, and don't get stuck painting tiny details that nobody will ever see. When you're setting up your drawing application, you want to set up your layers to make it easier for your PCB designer to work with the output. So some layers are additive. This means when you draw something on them, you add that thing to the PCB design. And some layers are subtractive, which means when you draw on them, they take things away. They cut bits of that layer away. So silk screen is additive, mask is subtractive, and copper can be both. So this is what this looks like. So on the left here, you have a circuit design with no art on it. And then we have additive layers and subtractive layers. So we have board, copper, mask, and ink. And then combining those, it results in the thing on the right. Okay, and here's an example layer setup that you can use in your drawing tool. So you have an ink layer, and then you have a bunch of groups, and you can set their opacity so that you can see the things underneath. And underneath all of that, you have a locked layer, which is the export that you got from your PCB design, and then you're drawing on top of that. So we worked in Krita. Krita is amazing, by the way. I just want to gush about that a bit, but yeah, we don't have time. So you want to be setting the blending mode to normal or erase, depending on whether it's an addition or a subtraction layer. And you can do this for silkscreen, you can do it for mask groups, and you can do it for the masks, and you can do it for the copper. So once you have this set up, you can then work in parallel. So each of you can go away and work on your own thing. And you want to check in with each other frequently to see if someone is doing something that will cause a disaster. And if you reach something that is especially difficult to work around, check if it would be easier for the other person to fix. Because very often, a 2-minute fix for one person can be a 4-hour fix for the other. So yeah, if you're spending hours like trying to work around a particular trace, then just ask, can this be moved? And usually it's like, yeah, sure. And yeah, no need to waste hours of your time when you can just communicate a bit. Okay, and you want to be re-exporting files when things change, just to sync every once in a while and to practice your round tripping. So when you're done with the art, it's time to export it. So you're exporting a board outline, possibly with holes, as a single line SVG. And then you're exporting your technical layers as individual SVGs if possible. So if they're raster images, we used Inkscape to vectorize them, which worked quite well. So you want positive copper, you want negative copper, which is the holes in your copper layer, you want positive silk, and you want negative mask. And you want that for each side of each board you're making. And it's really useful to add an alignment feature in each file, because then that lets you align the layers together once you import them in your PCB design program. PCB design programs are not made for art. They're not happy with working with this kind of stuff. And by adding an alignment feature, it helps you align the layers so that you can figure things out later. So we used KiCad for import, and KiCad has gotten significantly better since we first started doing this kind of stuff. So it's now possible to import an SVG with multiple shapes in it on any layer, and they end up as a group, and you can individually edit each one of them, or you can move the whole thing and transform the whole thing as a whole. So everything other than negative copper, you can import directly on the target layer. And for negative copper, you need to import it on another layer and then transform it to a keep out zone. That's the only thing that was weird with KiCad. But everything else worked out. Okay, so then once you've practiced this and you've gotten to the point where you have your final circuit and your final art, they come together, and then you'll find out two things. One, neither of them is as final as you think. And two, you'll be real glad that you did the round tripping earlier. Okay, so remember this. The black text here is from our original planning notes, and the red text is from when we attempted to integrate things. Lots and lots of things went wrong and needed changing, and also, fuck Photoshop. So this year, we learned from this. And we only needed to make much more minor changes. So for example, here, we had some features which were too small to manufacture. So we needed to redraw those. And yeah, in this case, like this is on the top left, you see what the artist originally planned. And these, the gaps between the leaves are all too small. So we needed to modify that, and you can see on the right the result where we removed the gaps that were too small and merged some of the leaves together so that it worked better. Yeah, so it was much less effort this time around because we had the process mostly figured out. So then it's time to finally manufacture the thing. PCB manufacturers expect normal boards. They expect things to be PCBs with pads for electronic components, and they're not set up for weird things. They also really like to use automated tools for manufacturing planning. And when you feed these automated tools artistic boards like this, weird things happen. I have crashed 2 PCB manufacturers so far. To their credit, they no longer crash when I send them files like this. But I think they've just put in checks that go, OK, too weird, manual review. Yeah. PCB manufacturers actually really love pretty boards. One factory that I once visited in China has a wall with all the weird and pretty things they had made, and you want to end up on that wall. And in another factory, I had a nice PCB with me, and the worker recognized it from when they were making it, and just stopped me and like, hey, I know this board. Yeah, so like they actually really appreciate this kind of thing, but you don't want to ambush them with things like that. So you don't want somebody to be sitting late at night going through the CAM results. That's computer-aided manufacturing. That's planning manufacturing for this board, and then go, oh shit, this is gonna be another hour. So communicate with your PCB manufacturer. And they will try to make assumptions about your boards, such that like every exposed copper pad needs to be solderable, or connectivity between any pair of connected copper pads needs to be established. And they will refuse to make boards where they cannot actually make that happen. So you need to give them permission. You need to say, like, I know this is weird, and I know this will not work for a normal like soldering. We're not putting any components on those pads. It's fine. If they're a bit weird, if they're the wrong shape, we don't care. Please manufacture it anyway. It's fine. And I very often go outside what PCB manufacturers promise to be able to manufacture. And by giving them this permission, having this conversation about it with them ahead of time, this lets you make things that are otherwise not doable. So yeah, we only have a couple minutes left. So I'll just give you a summary of everything. So you want to make plans, but you don't want to let them get in the way. And you want to round trip early, round trip often. Communicate with each other. Try to see whether you can make each other's lives easier. And if you're spending too much effort on something, ask the other person if it's easy for them. And communicate with your board vendor. Warn them what you're doing. Talk to them about what processes they have available. Sometimes they have really weird processes available that they will not offer normal customers because they're not reliable enough. But if you talk to them, they will try weird things for you. And end up on that wall. Make beautiful things. Yeah, that's all we have to say. Thank you. And Morag, unfortunately, cannot join us here, but Morag is on IRC and currently reading this, I hope. Yeah, so they can answer questions on IRC, and I can read them to you. So, yeah. we'll take questions now.
Right on, fantastic talk, thank you. Yeah, we have already a question over there, thank you.
Yes, is it possible to use tint copper as a fifth color?
Sorry, repeat?
A tint copper, or like a paste mask for art?
Yes, it is. The question was, is it possible to use solder on top of the copper as an additional color? And yes, it is. And again, this will cause PCB assembly companies to get weird about it, because they're like, why is there paste on there? No component. Why is the paste that shape? Can we change the shape and the color of the paste? And you need to give them permission. But yes, that gives you an additional color. So Morag wants to say, thanks for joining us, everyone. And Clement has done a great job talking for me, so big thanks to him. Okay, more questions?
Yeah, the signal angel all the way down.
We have a question from the internet, yes. What was the largest file size of a Gerber set you sent to a manufacturer?
Okay, so the problem with large Gerbers has gotten much better with modern KiCad because we can work in an entirely vector process. Previously, we had to export things to raster and back again, and every little dot ended up like an individual shape. And I think I've sent like 70 megabyte Gerbers. Please don't do that. It makes their automated checking tools super unhappy.
I have a feeling that more artistic PCBs are coming on the market, so to say. Do you think that that will cause developers to make it possible to make it easier to create artistic PCBs in the software?
Yeah, do I need to repeat that question, or is it on the stream already? Okay, yeah, so I do think that this is already happening. So like there's already like PCB design tools that are adding better graphics import. The graphics import in KiCad got dramatically better between version 7 and 8. There's Horizon PCB, which is another open source board design tool, which introduced like importable, scalable graphics, which you can scale inside the PCB. So yeah, this is definitely happening. There's even like artistic design tools being made specifically for PCB art. There's something called Boatport, which I believe is not currently in development, but it was an experimental project for making PCBs inside a drawing tool. So yeah, this is definitely happening, and I think it will continue happening. But this is an industry that moves slowly, and we're going to need to push it from below, and we shouldn't expect too much.
All right.
Hi. So the last time I was trying to build a beautiful PCB project and print it in Europe, I was failing on finding even a manufacturer that would do solder mask that is different than green. So do you know if there are European-based manufacturers who may be able to help?
Yeah, this is really difficult. So European-based manufacturers in general tend to not have that much variety because of reduced scale. And I think it's mainly a demand problem. Like if we pester them enough, it will happen. But again, this is a slow-moving industry, and there's several major manufacturers in China who are way ahead on this in terms of variety. So it's...
So maybe it's something we should nudge collectively and start an initiative to get them
Yes,
to do
please,
this.
European PCB manufacturers, make pretty things. Let us make pretty things.
Yes, exactly.
I know it sucks for you.
So the colors for the silk screen, were you able to like set custom ones with the manufacturers, or do you have to just choose from pre-selected ones that they have?
Usually they'll only do pre-selected ones. If you are making a lot of PCBs, they will do a custom cover. The problem is the machine that puts the mask on, you need to put in a certain amount of ink into it. And if you then need to change that cover rapidly, then you waste a lot of ink, and it's a major mess to clean. So like this is like a half-day extra effort for them to do that. So you need to make it worthwhile.
Mike 4?
Have you tried converting the copper to patina on one of those things?
Sorry, to what?
Patina. When you let copper expose it to air and moisture, it gets green or something.
Yeah, so I've not tried to do this. So usually copper that is on a PCB gets a protective coating. You can tell the vendor to not put in that protective coating. They don't like doing it, and it makes it much more difficult to solder and handle the parts. But it is technically possible. I've not tried it.
Thank you.
So art changes because of the design of the PCB, but then how often does the design change how the functionality of the board is made? Or is it more like art adapts only to the board?
Okay, so yeah, that's a more philosophical question about like design process. So if you're doing a collaboration, there will usually be some co-design where there's back and forth happening. And definitely in the idea phase, this happens a lot. So it's like, oh, we could do this, we could do this, we could do this. And it's really hard actually to like scratch out as many of these things as possible so that the project remains viable. But yeah, definitely the art influences the electronics, and the electronics influence the art. And to the question earlier, Morag would like to respond. I will get my wire wool and vinegar out because that's a really interesting idea.
Well, and with that, I think we have a closing. Thank you again.